Hello everyone, and welcome to the webinar, Adventures in Crowdsourcing, Modern Data Management. My name is Kevin Vita, and I'll be helping with facilitating today's webinar. This webinar is sponsored by the Federal Highway Administration and hosted by the National Operations Center of Excellence, also known as NOCO. As a quick reminder, if you don't know already, at NOCO we offer a variety of resources to support the transportation systems management and operations community. On the lower right side of your screen, you will see a box called Useful Links. It's actually on the lower part of the screen, sorry. You can browse through those links for TSMO resources and news. Previous webinar recordings related to this topic can be accessed from there. Now I'll cover a few logics for today's webinar. We are recording this webinar, and the recording, along with the presentation slides, will be available through the on-demand learning section of our website. All of the attendees are on listen-only mode by default, but if you'd like to stay engaged by using the question and discussion pod for comments and questions. We'll have a question and answer session at the end of the webinar, so if you have any questions, we encourage all of you to enter them in the questions pod as they come to your mind at any time. The questions will be read out loud one at a time by the moderator, and our presenters will answer each question. So that's all I have, and with that, I'll hand it over to our moderator, Greg Jones, to start us off.
Great, thank you, Kevin. If we can get the slides up for the presentation, please. Welcome, everyone. This is our another one of our webinars on crowdsourcing for advancing operations. Today's topic is modern data management, and our legal office just ask us to give a quick disclaimer that we may present names of manufacturers, companies, products during the course of these webinars. They are only used as examples. We are not endorsing any of the products or manufacturers. Today's agenda will have a quick background discussion about the innovation for advancing operations with crowdsourced data. Then we'll have three presentations. The first will be platforms to support emerging data. The second will be data business plan. And then the third will be a joint presentation on data strategy by the Georgia DOT and the Atlanta Region Commission. As Kevin mentioned, if you have questions that come to mind as we go through, please put those into the question and discussion pod. And after we complete all three of the presentations, then we will have a question and answer session at the conclusion of the last presentation. Today's participants, and I will be your webinar host today. I'm Greg Jones. I am with the Federal Highway Administration, and I have a joint position where I work with the Federal Highways Resource Center operations team, and I also work with our Federal Highways Headquarters Office of Operations. Our presenters today will be Ben Pachu. Ben works at the AEM Corporation. Walter During works with Federal Highways Office of Transportation Management. Matt Glasser works with the Georgia DOT. And Kofi Wakhisi works with the Atlanta Region Commission. So again, just to give a little bit of background about Everyday Counts and our specific initiative on crowdsourcing to advance operations. Everyday Counts is a state and local based model that identifies and deploys proven yet somewhat underutilized innovations. The goals for Everyday Count are to shorten project delivery, enhance roadway safety, reduce traffic congestion, and integrate automation. The two main goals for our particular innovation are in the enhancing the roadway safety and reducing traffic congestion. So why would you do crowdsourcing for operations? Well, again, as I mentioned, these are have been proven benefits of using crowdsourced data for operations. You can improve the operations efficiency. You can also increase the safety and reliability of your operations. as well as there's potential to save costs in certain applications. And so this is why we feel like this is an innovation that should be promoted and utilized more thoroughly than what it has been up until this point in time. Some of the application areas have been used in up to date. Things like traffic incident management, where you identify and respond to incidents on your transportation system through information that comes through crowdsourced data. In the area of traveler information, primarily that helps with providing accurate travel times and speed data. For traffic studies, you can use real-time and archived crowdsourced data to be able to complete studies that would give you cost and benefits of projected projects. In the area of performance management, you can monitor crowdsourced data in real time to look at operational performance, as well as look at it in an archive state to look at performance over time. From road weather, you can collect data from weather management sources and equipment and field applications and integrate that in with the operations program to better facilitate management during certain weather conditions. From the arterial management, you can get information on traffic flow on arterials as well as signal operations, and that can help with signal timing operations as well as performance measures on arterials. In the area of freeway management, again, you can get travel time and speed data from freeways, and that can help cover areas that may not be covered within agencies' existing capabilities through their field equipment. So you may be able to expand considerably from what you may have under agency coverage with their particular field equipment. It can also, the crowdsourced data can also be used to help with project prioritization as you go through the planning process, being able to use some of the data, doing cost-benefit types of studies, looking at how operations projects can be utilized within a region. Crowdsourced data can help with work zone management, getting data from work zones and being able to make decisions on the management of those work zones. It can also be used in emergency management, in particular in response to events such as flooding and fires. You can monitor travel data, and you can also monitor certain weather data that would help give information as things such as evacuations or road closures. Crowdsourced data can be valuable for identifying areas where maintenance needs would be and being able to improve both physical pavement maintenance as well as ITS equipment maintenance. And the great thing about crowdsourced data is we're finding new applications all the time. And we actually had an innovation in EDC5 which ended last year, and it was carried over to EDC round 6 that started at the beginning of this year because there are so many application areas that are blossoming that we felt like there was a lot of potential to continue this innovation and move forward. So with that, I will move it over to our presenters, and the first presentation is going to come from Ben. Ben is the Chief Data Scientist at AEM, and Ben, let me turn it over to you.
Hi, I hope you guys can hear me. Please let me know if there's an issue with it. Well, thank you very much for coming. So I will be presenting the platform in support of emerging data, and particularly related to the cloud and the reason why the cloud exists and why it needs to be adopted to some extent. So data today pretty much is, as everybody's been saying for the last 10 years, growing at an exponential rate, but what you see on the graph on the left was pretty much the typical traditional business data in orange. And then in green, you're seeing pretty much what's referred to as human data, which grows about 10 times faster than the orange data, which is the human data. So you can think about actually what's crowdsourced. Typically an application like Waze would generate human data. Anything that's pretty much is related to a human entering a button, a pushing a button, or actually doing something, maybe indirectly with an application. The one that is now the most concerning is what is referred to as sensor data, and it's kind of in bluish on the diagram here, which this one grows about 50 times faster than business data. And this is related to pretty much IoT, and this is what you see on the right side. Since the IoT inception, which pretty much was in 2008, 2009, every single device from your coffee machine to a traffic signal to connected vehicle could be implemented in there, or even sensors within these infrastructures is becoming connected and is generating a vast amount of data that is becoming even more challenging than the ones that were created in the early 2000s to deal with. So the traditional way of dealing with data that most government agencies are still using is based pretty much on relational database management systems that were created in the 80s, and that's the little diagram that you see there. Usually it means using structured data that goes through an extract, transform, and load process called ETL that goes into a relational database. That relational database has a data model, a data schema that is designed for a specific purpose, that is meant to be rigid and not easily modified for the good and simple reason that you're trying to protect your data. And you don't want the data is clean, reformatted in order to fit the schema. It's called the schema on write. And from this data inside the schema, reports and dashboards and queries are being performed by only a few users. Don't want to open it to too many people because you want to limit data corruption and deletion. And these typical setups work well for limited amount of structured data, but they're starting to have some issue with keeping up with the volume, the speed, and the granularity, and the demand for data analysis, where more and more people want to do a data analysis. Data is changing faster, growing faster, and it's more and more refined. And they become extremely expensive to maintain and extremely expensive to scale, and they were not meant for this kind of change. Just a quick summary here. We can see pretty much this is just open source database technology that existed from 1994 to 2014. You can see MySQL, Postgres started in 1996, and then you have things like Netezza that was started by IBM. Not a very, very powerful relational database that happens around 2004. But you see very few systems have been developed to try to increase, but they are pretty much the relational database model. Starting 2007, you pretty much have an avalanche of systems that pretty much follow the advent of Hadoop that were designed to cope with these challenges that I was talking about in the first slide. And this is just the beginning, and it hasn't changed yet, and it's still. So you have an avalanche of products that keep changing to try to analyze the data, to search the data, to organize it as fast as possible, trying to keep up with the race that it brings. At the same time, you have obsolescence. So obsolescence is the time when a technical product or service is no longer needed or wanted, even though it could still be in working order. And this affects everything. Hardware, storage, computing units, pretty much CPUs and memory, networks, software. Typically, softwares are being changed sometimes on a 30 minutes, if not a 10 minutes basis, especially on the web. And most of the development now, about I would say 60% to 70% of software developments are like somewhat automated. And that means there's even more facilities to create new software or change them fast. And also workforce, the half-life of degrees and certification is decreasing. To give you a little estimate, the half-life of somebody who graduates with a software or computer science degree right now is about 2.5 years. Back in 1966, it was 25. So on the right, you have a little diagram that shows pretty much the drop in price of different database sizes from 1 terabyte to 6 and 8 terabytes. And you see how long they last, pretty much how much they stop being priced and how they're being replaced and how quickly the price comes down. And this is a challenge when you're trying to build systems, especially on-premise systems, because the investment in the capital investment that you're putting in any kind of infrastructure to store data or query data becomes obsolete, and you don't have the time to recover the investment that you had on your system. So the situation we're in, there's no one-size-fits-all solution to analyze data anymore. The relational database has kind of limited, and a lot of different tools have been created. So that diagram on the side shows pretty much the different categories of tools that exist now to analyze data. So you have your traditional relational database management system, still valid, it's still there. You have the data warehouse that is pretty much a group of relational database management systems with different processes to try to extend its capability. Then in 2006, you had the advent of Hadoop and anything that's Hadoop based, which is kind of phasing out right now and is pretty much batch oriented. And then off of Hadoop developed NoSQL. They were more like easier to use databases that were mostly designed for the web that could deal with a volume of data that was much, much bigger. Then NewSQL, which was pretty much the concept of Hadoop that was applied to relational database in order to have the advantages of relational database with the redundancy and distribution of Hadoop. And these are pretty much replaced relational database in most modern systems now. And now you have the advent all the way on top in what's called in-memory and GPU databases, where the NewSQL databases did not go fast enough, especially for IoT. And parallelization is now being done to hardware through analysis. The data in analysis doesn't even go to disk in order to go faster. And so you have the use of GPU and in-memory database that can be up to 40, 50, 100 times faster, to the point that you could analyze, 5 billion records on a laptop without any problem if you have a GPU and a good amount of memory. So these tools, they're often expensive, I would say, to implement, and they require many servers, they're clustered, and they're pretty expensive to acquire, and they have a lot of maintenance. So the shortcomings of adopting something like this is that you have to pretty much build a huge infrastructure to not necessarily do do not use it at all entirely for all your queries. You may use, maybe you may use the infrastructure like this maybe 20% of the time overall compared to its actual capability. And this is why the cloud was actually created. It was pretty much designed to be a shared IT resource where these systems, these new data systems, could be implemented without having to carry the burden and the cost of having the infrastructure needed to use them and share it with others. So what's the cloud? Well, pretty much the cloud is an on-demand service, self-service with a broad network access with multiple resources, multi-tenancy pretty much. You have several people. It's pretty much several data centers that have the same software where you can pretty much get different types of services. It has very rapid elasticity, so if you want more storage or more compute power, it pretty much can provide it on demand as long as the data center and the demand is not too high and there's availability. It's measured service, so every single action that you do on the cloud is pretty much being metered, and that's what that's what's being used to charge you. You pay for only what you use on that resource. Now, this is a kind of a funny analogy of the type of services that have happened on the cloud and that started. And to the left, you can see the traditional on-premise, where pretty much, and the analogy is made with pizza, so you can pretty much find the equivalent there. But pretty much, you control everything from the hardware to the configuration. If you look to the right, there's the equivalent computing things on the side. And the first thing that happened on the cloud was the infrastructure as a service. So pretty much the hardware and virtualizations allow you to pretty much have a set of computers that you could use instead of buying your own, installing them and maintaining them in-house. Then they evolved this into container as a service. Virtualization of the whole OS was a bit difficult, so they pretty much streamlined the virtualization system and made virtualization of much smaller machines that would start much faster. That was a container as a service. And these services all exist at this point. As the people started using the cloud, they wanted to disconnect themselves more and more from the software and some of the servers or services that were running on them, the hardware and some of the server and services that were running on them. The platform as a service, which pretty much would be the runtime that is pretty much managed by the cloud all the way to hardware to the runtime. So the typical example is if you want a relational database, if you want a Hadoop cluster, if you want a web server that's redundant and elastically scalable, you can subscribe to these services that they provide, and you just build your website on top of them, and you don't have to worry about anything that happens. If there's a surge in demand because it's winter and people want to see where the snow plows are, that system will automatically scale for it, and you won't have to figure out how to make money for it. The function as a service is a bit more modern, newer. It's something that relates to what's called microservices architecture and the system of systems approach. It's pretty much where single functions that typically would be in a program are now being run into containers independently. It is a rather different approach, but it is pretty much becoming the predominant one now. And finally, software as a service is pretty much where the cloud providers pretty much bring you an entire service that you want to use. So for example, data analysis service, where you would have a web interface and you would load your data in it and have dashboards and do queries and without ever knowing what happened behind. Now, so the modern data warehouse still has the traditional data system, but it is pretty much becoming just one of the multiple things that can be done with the data. And everybody heard of the term data lake. The term data lake is pretty much a big dynamically managed repository of data, but that data is being loaded from data sources as is, without being cleaned, without being reformatted as is. Now, the data can be added on to with some, for example, quality metrics or different access rights or things like that in the data lake. But in any case, it's never being altered in order to allow the maximum value to be extracted from the data. The data lake is a scalable storage, so if you have new data sets that are coming, you can always have room to have them in there. And the data is then, rather than being loaded directly with one single ETL, has different little ETLs, if you want, that are created for every single project that's using it based on the tools that they're using, which may not be a traditional relational database. It may be a graph database, maybe a search engine.
Brandy, it is viewing the URI.
Okay. So now this data lake is now migrating in 2021 towards more of a real-time data store in the age of IoT, where data is pretty much being added on in real time to the data lake in different data streams. Now, a quick cost comparison. This is actually from, I think this was in CHRP 2103. I think the report is 865. But pretty much this is a comparison, a quick comparison of a table between a server that would be equivalent with 1 billion input-output request for a 10 terabyte of storage in the relational database with 100,000 terabyte backup. And you can see that the licensing fees for something like Oracle and the annual maintenance and support will get you in the area of about $3 million per year. If you use an open source alternative like PostgreSQL plus a service that's on an IBM Power Linux server that is equivalent, pretty much, you would be around $80,000. And if you were to purchase AWS Aurora and have a similar servers doing something like this that can scale, it would be about the same cost. So these costs do not include the personnel and the management for the first two cases, but AWS pretty much has it included in there for the AWS Aurora. But you have to be careful about the changes because because of pay-as-you-go nature, if you have long-running queries or if you have instances of software that are disconnected and you forgot about that you do not shut down, or you forgot that you have data stored in the data lake, or just like in the case of somebody from Virginia mentioned that to me, you have a huge snowstorm and suddenly half the states wants to see where the snow flows out. You may exceed the cost that you're seeing on that spreadsheet very quickly. And this is something where you have to be much more proactive in monitoring the cost of the system when you use the cloud than when you do on-premise. So the cloud seems pretty good. It has elasticity, it requires vigilance, but why is it this holy grail is the greatest thing? So yes and no. It is great for dealing with IoT data, but it has limitations, and there are cases for on-premise versus the cloud. So on-premise, because sometimes you have to meet government regulations, especially for meeting sensitive data, although there are clouds that have that are now certified in order to have sensitive data on it that you can purchase. It's becoming more expensive. You want to need for an advanced security beyond the cloud offering, and what the cloud offerings are. Usually the cloud is pretty advanced in security, but you may not be able to do it, or there's still like the visibility of data residency. You want to know where the data is, and some organizations still want some of their data in-house in the building. They feel better having it there, which is completely understandable. The bandwidth constraint for the accessibility of the last mile, which is if you lose connection to the cloud, what happens? Some people actually keep a smaller amount, a copied smaller amount of data on their on some on-premise architecture, so they could keep working and then resync with the cloud in case they lose contact. I don't know if you've seen the news. There's a big company called Fastly that just went down not too long ago that took several websites down across the world because of this. So this is in case these things happen. This is what you would want to have. So they're extremely rare, but they still happen. And I guess a more direct control over latency, which is becoming less and less relevant. But there's still, you're working on a remote device. So if you want really, really fast data processing, sometimes you want to be on the premise. Why the cloud? Well, because you're shifting the risk of IT infrastructure obsolescence to the cloud provider. They're the one taking it, having to change it constantly. You just don't have to worry about that. The scalability, flexibility, on-demand nature of the IT capabilities, where you can pretty much dial in or dial down as you need. And the cost of IT infrastructure operation and maintenance is pretty much reduced to because it's shared among other people. It's reduced extremely to a much lower cost than if you were doing it on-premise in-house. And then the lower cost profile of most of the services that you will have, and particularly security, because you are often, it's difficult to hire people with specific cybersecurity expertise that, I would say, cloud providers have the ability to hire, that it's much more difficult for organizations to do. Another catch, if you transfer an architecture or traditional architecture to the cloud, you won't necessarily have that many benefits. If anything, it will maybe increase the cost, because as we've seen on that table, you'll be paying for the licenses of your relational database, of your web servers, your Windows OS licenses, and then you'll be paying for the pay-as-you-go system as well. which will end up being a little bit more or about as much as on-premise, so you won't see really an advantage in doing this. In order to take advantage of the cloud services, the resiliency, the pay-as-you-go, and the scalability, you pretty much have to kind of re-architect your system to be more distributed and to take advantage of this distributed architecture that the cloud offers. The other one is the vendor log. The cloud providers are giving you a lot of very easy software for you to turn into that architecture that is distributed so you can benefit from this. But they will make it in such a way that it is very difficult for you to move out and move to a different cloud provider if needs be. So for that, there are software such as Kubernetes now that allows you to create cloud agnostic architecture. So this is an example of a distributed architecture system. This is from NCHRP 2903, where the different layers are of abstraction layers in between, and the processes are pretty much built-in components in between. This is pretty much the distributed system with the arrival of new components and interfaces, going through the abstraction layers in order for you to be able to evolve your system through even though it's distributed, and it requires attention to pretty much everything from the event logs, the rules and policies, data governance, security, and management. So it's really a complete redrawing of the way you run your system. This is a quick summary of the comparison of data management pretty much between a modern architecture and a traditional one. And what you have is that pretty much the focus becomes, and I'm not going to go through every single one of that one because I'm running out of time, but 80% of the resources in traditional were pretty much meant to monitor the system and manage the system and manage the data tightly. And only 20% of these resources are really needed for the cloud, and 80% of the resources need now to be spent on data analysis. Right. Now the transition, how do you transition to them? This is another diagram from NCHRP 2103. Typically, system migration, you go and you create a complete new system after the other one is done, and you migrate. In cloud, it is better to start migrating pieces and keep things on premise tied to the clouds and kind of go one bit by one bit slowly so you get acquainted and you can catch errors. So this allows for a slower transition with less risk and often to better understand the cloud system and the architecture transition that you need to do. And if you want to know more, pretty much NCHRP research report 865, 952, and 904 are available to learn a little bit more about what I just talked about. Thank you.
Thanks, Ben. And let me just remind everyone once again, on the lower right side of your screen, there's a question discussion chat pod, and that's where we'll take questions. We should have enough time for probably around 3 questions per presentation. So if there's anything that's fresh on your mind now, please go ahead and enter that into the chat pod. And with that, we'll move on to our next speaker. That's Walter During. Walter is with the Federal Highway Administration, the Office of Transportation Management, and part of his job, he oversees the USDOT Mobility Data Business Plan Charter, and he serves as the chair for its ongoing implementation. So he's going to be talking about Mobility Data Business Plan today. So with that, Walter, you're up. Please start up.
Yes, good afternoon all. Can you hear me, Greg?
Yes, you're coming through fine. Thanks.
Oh, thank you. Starting off, I will be talking about the data business plan. In FY 2009, our Office of Transportation Management identified the need to investigate inconsistencies between USDOT data program officers. The outcome of this study identified gaps in data, coordination, standards, and governance. The recommendation from this study was that the USDOT considered developing, implementing, and maintaining a data business plan. A data business plan is a plan for efficient use of persons, processes, and technology that links business objectives, programs, and processes to data systems, services, and products, and guides an agency in the data management practices. So consistent with NCHRP 666 that recommends starting small when implementing governance within an organization and then expanding upon it as you mature, the USDOT Roadway Mobility Data Coordination Group was formed to facilitate cross-organizational collaboration, data sharing, and integration of roadway travel mobility data to address gaps, redundancies, and avoid investing resources in the same or similar types of data-related programs. Roadway travel mobility data includes speed and volume data, climate data, modal data, and data associated with connected vehicle technologies. The group is also charged with addressing cross-cutting data management issues such as quality, standards, privacy, and security. The benefits of a data business planning are the following. It helps local partners identify what mobility data is being collected within their organization and at the regional level, how the data supports mobility planning, operations, and performance measure activities, and then also lets you know who is responsible for managing and updating the data. At the same token, it solidifies working relationship by identifying partner agencies on how it helps how to share and exchange the mobility data both internally and externally. Then it helps identify potential duplicative data collection efforts, which leads to a more rapid and targeted data acquisition process, thus saving costs. The background of this effort is as follows. It is a multi-year effort that is funded by the Office of Operations, which resides in by the Office of Transportation Management, which resides in the Office of Operations, where we first developed and implemented best business practices in data governance and management. Then, at the request of external stakeholders who thought there was the federal role for USDOT to assist with the facilitation of in the development of regional mobility data business plans, especially as we move into the connected vehicle era, this program led the development of a guide to provide assistance, and the draft guide was test piloted with Hillsborough MPO, Mid-American Regional Council, and Maryland DOT. So based on lessons learned from the 3 pilots, the guide was refined and published as shown on this slide. The next slide shows the published pilot reports for the 3 piloted sites, namely Maryland State Highway, Mid-American Regional Council of Government, and Hillsborough MPO. The data business plan guide contains 9 steps, and I intend to highlight them within the remainder of my allotted time. Starting off with step 1, which is the establishment of needs and objectives. Here, the work group defines the high-level challenges and develops the outcome statement. For the high-level challenges, 3 areas must be visited. The first area is that of data system in terms of the data collection process. We need also to identify duplicative efforts, address storage needs, data quality standards, integration, and also documentations and access issues. In the second area, which is that of technologies and tools, software, hardware, system interface, IT compatibility through analytic tools to network issues would need to be addressed. Then in the third area, which is that of management and governance, here we need to define business rules and processes through the coordination of resources, availabilities, and training needs. The outcome statement describes the results that the data business plan would achieve. Therefore, here, the team will develop the framework and the process for developing, collecting, calculating, and reporting on performance measures. Step 2 is that of stakeholder outreach. In this phase, the work group would identify and document stakeholders, then develop stakeholder registry and outreach plan. In identifying and documenting stakeholders, the work group would first identify the core stakeholders, that is the so-called champions. Then they would identify their internal stakeholders to be followed by the external stakeholders in terms of the entities with whom they share data. The work group will then define the stakeholder outreach plan. These engagement mechanisms define how often they meet, the type of focus groups, how knowledge is transferred, how success is measured, and how accomplishments are reported. Step 3 is that of data assessment. In this phase, the work group would identify data sets and business uses, develop data inventory, and conduct the assessment. This slide shows examples of data sets with their corresponding business uses. So back to the slide. For example, here you would see that for integration of speed and volume data, the business case would be that for mobility performance measures. The work group then develops the data inventory to increase knowledge of current and future data collection activities in the region. Here, the work group will identify the agencies, types and sources of data, collection methods, network types, the geographic boundaries, time period, and for what purpose. This is what I would usually refer to as the who, what, how, where, when, and why question. Next is to conduct the maturity level assessment in these identified areas, starting with assessing their current levels of maturity. After establishing the current levels of maturity, the work group will identify the desired levels of maturity and specify if gaps or no gaps are desired at these levels. Then step number 4 is that of the conduction of gap assessments. The work group will identify gaps and overlaps that exist in the program activities, namely data systems, technology and tools, and governance, culture, and collaboration. I previously identified these gaps in step 1A, which is that of the definition of high-level challenges. Step 5 addresses the improvement strategy. For the improvement strategy, the work group identifies priorities in terms of low, medium, and high, and then assign responsibilities and implement the schedule. In the development of data governance process and documents, which is that of step 6, the work group would agree to and develop data principles and their governance model, and then would formulate roles and responsibilities and document the governance program. The published USDOT guide uses the valuable, available, reliable, authorized, clear, efficient, and accountable data principles. This slide shows a governance model that is included in the USDOT published guide that we use to provide assistance in facilitating the development of regional plans. Next is the identification of roles with their descriptions and responsibilities, to be followed by the development of documentations for the data governance manual, which would include policies, standards, roles and responsibilities, the data catalog to document data system and office responsible for managing these systems, and lastly the glossary that defines commonly used business terms. Step 7 is that of data management practices. Here, and this is for the implementation of data management policies and procedures for data collection, processing, analysis, and integration in the 9 identified areas, namely data acquisition, data quality, standards, business analysis, privacy and security, data storage and access, performance measures, risk assessment, and knowledge management. Step 8 is to develop the implementation roadmap, which encompasses 5 steps. Step 1 is the execution of the Memorandum of Understanding. In step 2, we need to obtain regional buy-in. Then in step 3 is for improving data integration and collaboration, while step 4 builds on the data sharing platform, followed by step 5, which is the implementation of performance measures to track success. Step 9 is the development of the data business plan, which in a nutshell is putting together all the hard work that you would have done moving from steps 1 through step 8. So this is the process that USDOT follows in providing assistance to local jurisdictions in facilitating the development of regional business plans. FHWA objective at a glance is to It includes presenting FHWA's approach for the mobility data business plan. We also raise awareness about the benefits of coordinated mobility data management and planning, and furthermore, we provide assistance in the development of high-level approaches for regional data sharing frameworks. The current phase of this effort is a series of workshops to raise awareness about the benefits of the data business planning, and also to spur regional collaboration, and finally to advance the technical abilities of workshop participants. To date, this program has conducted 7 workshops. We started off with Atlanta Regional Council, then we had a workshop with San Diego Association of Government, followed by Nevada DOT, and to be followed by Wichita MPO, and Maricopa Association of Government, and lastly Buffalo, the Niagara area, for which we were able to facilitate the development of a regional plan among 16 jurisdictions. Lastly, if you would like to get in touch with me to know how USDOT can provide assistance to your organization, please don't hesitate to contact me at the shown address, that is via email or telephone. Thank you. Back to you, Greg. Good.
So Greg mentioned that he lost his connection, so I'll move on and introduce our next presenters. We have Matt Glasser from Georgia DOT, and we'll be starting with Kofi Wakhisi from the ARC. Take it away, Kofi.
Hey, thanks, Kevin. Good day, everybody. My name is Kofi Wakhisi with the Atlanta Regional Commission, and I am going to kick off our presentation and first give you a little bit of a backdrop on what was happening or what is happening in the Atlanta region and the state of Georgia. So quick sort of, I guess, snippets of milestones over the last couple of years would be back in 2018, we, the MPO, initiated the first ever region-wide TSMO action plan, strategic plan. And along with that, it included updating the regional ITS architecture. One of the scope elements of that work was to establish some data governance guidance. Because ARC being the MPO, we have historically been sought out for regional sets of data, of course transportation related, but also land use, demographics, economy, economic data, etc. And so the data governance work that was undertaken as part of this scope specifically dealt with transportation and performance data relative to TSMO, ITS, traffic operations. And like Walter said in his intro or in his remarks, the connected vehicle, autonomous vehicle emergence was one of the, I think, one of the main motivating factors for our staff and our board to sort of sanction this study, trying to figure out how do we manage not only aggregated historical data, but what role does ARC as the MPO have in brokering or managing or sharing, publishing either real-time or post-real-time data associated with connected vehicle or autonomous vehicle. What is that going to mean? How does that look? to all of the different local governments who are the infrastructure owner and operators, and what is GDOT, doing as far as that is concerned. So we wanted to just have a broad conversation. So we wrapped that up in 2020, and excuse me one second. We wrapped that up in 2020, and we had a data governance report. And then in part during that time frame in 2019, ARC, GDOT, and other agencies in Georgia participated in one of the data business plan workshops that Walter had described. And you can see here on the slide, as we were finalizing the data governance report, and as we were sort of in the middle or getting closer towards the end of the TISMO strategic action plan, we sort of synthesized that workshop, the results from that workshop, as follows here on this slide. And we realized there was a lot of nuance happening, because different agencies, it's one thing to pursue a region-wide data set or a region-wide pooled data program, but each operator or agency has different requirements for the data. And in the private marketplace, there doesn't seem to be at the moment a sort of silver bullet data provider where the data they provide through a single use or multi-use license would necessarily handle all of the nuance and needs for various different agencies for various different purposes. So that's kind of where we are, and Matt Glasser is going to kind of go into give you guys a little more insight on that. But you can see here that it's not just highway data that we're at the MPO are interested in, because of the way we think people are going to be traveling in the future. Is also requiring us to take a hard look at how we collect and share data. For example, this last bullet on this slide is raising a lot of questions and concerns about how do we not necessarily track travel behavior, but how do we measure performance of it for modes like micromobility, scooters, for example, and there's vendors now that can help MPOs and other agencies monitor and track that. But going forward, there's other forms of micromobility, or maybe just mobility as a service in general, where your trip might partly include driving or traveling on the roadway, but it will also include, it could include a transit trip that you planned. It can include a ride-hailing service, and of course a scooter, or you just walk. So we're still in the early stages trying to wrap our heads around what seems like a very exciting time, but also very challenging from a data management perspective. And so one of the things, between the business plan workshop that took place and the TISMO strategic plan, we identified some key initiatives that relate to data governance and data sharing, and that was initiated. Some of those initiatives have already been have begun thanks to Matt at GDOT in getting us started. We really appreciate the state DOT kind of taking the lead, because of course they're the 800-pound gorilla, and they've got lots of needs. But of course, MPO and DOT needs are slightly different. And then we also have to think about how do we loop in some of our other partner agencies like transit providers and local governments in the future. So I think this concludes my slide. I just wanted to give a little bit of context and backdrop as to how we got to where we are right now. And Matt's going to give you some more insight and complete this portion of the panel. So Matt,
thanks, Kofi.
Are you there? Okay, yeah, I can hear you.
I appreciate you getting me. Great. I appreciate you getting me started. And if I can, I was going to hop back to your slide to really just, I want to focus on this for two reasons. The first of which being that it's important for us to note that the remainder of this presentation is about this joint effort that we have going on, and that was only possible because we've been building and fostering this relationship for years, and because of ARC's leadership with doing the initiatives for the data governance procedure, the TISMA strategic plan, the ITS architecture, it really got us ramped up, got everybody going, got everybody in the right mindset to make this happen. So that's number one. And number two is that, it's very easy once you're done with those plans to just put them on the shelf, feel good about yourself, but then let nothing happen. And we're not letting that happen here. It's a little hard to read, but it's not there for you to stare at. But there are 8 initiatives and 38 actions that ARC outlined. And what we're going to be talking about today allows us to implement 7 of those 8 initiatives and 21 of the 38. With just one big action, we're taking a big chunk out of this. And I think that's something important to think about. So as ARC was finishing, GDOT Traffic Ops took the lead in organizing Georgia's overall collective response to the Eastern Transportation Coalition's Vehicle Probe Project RFP, which I think is either out right now or getting ready to come out. And we felt it was important to provide, not only to the coalition, but the overall data community a better understanding of the values, the needs, and the desires of Georgia. So with the help of our consultant Arcadis, we had several workshops to solicit input from the individuals, not just at GDOT, but ARC and the State Road and Toll Authority. And this table that you're looking at is an illustration of just the incredible overlapping needs between all those different groups. You have to go down to item number 8 before you even find an item that doesn't present a shared need between literally everybody. And this information, the associated interviews, were all compiled, built into this kind of, I will admit, a little bit of a snooze fest read, but we handed that off to the coalition. We shared that resource with several other states that were looking to do something very similar. And this is going to be added as a reference document. Again, the idea being to let the industry know where we need to be going. And so I'd like to share this example about the power of data, what we know that we need, and how can it evolve. So when we started this whole game, probably like many of you guys, we were buying speed data to produce green, yellow, red on a map for our 511 and our central ATMS platform. We used it for travel times on our DMS, and our Office of Planning was using it for federal reporting, which works great, and we justified it accordingly, and it made total sense. But this is where we are now, and this is just, very quick, high-level things that make that data even more valuable to us, right? So we were combining that data, using it for work zone monitoring. Our district offices, the TMC, our Office of Construction started using it for project identification and impact analysis, congestion scan, forecasting to better determine how to manage our reversible roadways. When the Super Bowl was in town, we could provide real-time updates and daily reports about how everything looked. And again, this is just the tip of the iceberg for this one data set that we have. And so when we look at another data set like trip data or origin destination, we're starting with something like this. We already know that it's incredibly valuable, and we know based off our experience that this thing is just going to balloon. So, and hopping right down into this, as we were concluding the ARC project, as we were ramping up these things, we knew that we didn't want this to just sit. We knew that action needed to be taken. And so we wanted to develop a comprehensive, centralized approach to start getting data brought in. And so we expended a considerable amount of effort and resources already to get these data, to get all this data already. We need to make sure that we're using it as efficiently as we can, that we're not, as mentioned in previous presentations, we're not duplicating efforts, which was happening and continues to happen. But we wanted to set up the framework for an overall group that wasn't just GDOT, but was multi-agency purposefully to make sure that we were bringing in everyone and set up those guidelines, set up the policy recommendations on how we purchase data, how we use data, and how we make sure that we're minimizing the overall overlap. And so the framework that we came up with kind of looks like this. It's meant to be a roundtable. And so you'll see here that there is a GDOT program manager who leads the overall effort, and the idea being that the group is going to collectively come to a consensus. And thus far, that has been the way that this has worked. As we've built the rules, as we've built our needs, our overall needs, it has been unanimous votes. Not a one has been has been objected to by anyone, which is, I think, great news and indicative of the fact that we all instinctively know that there are huge overlaps, and now that we're there, now that we're working together, we can see the fruits of our labor. We can see the fruits of our labor. And so, one of the big challenges that we face, and I imagine pretty much every other agency faces, is that we're going to our executive teams and asking for money. And while this field has been around for a while, it's understandably so. I think folks want to understand, want to know what's the business case, what's the benefit cost of us doing this. And so at a high level here on our left column, you can see what we're currently spending. And all of this is just hidden, and a big bulk of it is hidden in projects. So yes, the TMC is purchasing $1.1 million worth of statewide data and analytics tools for speed data, and that's great. And yes, we're spending $300,000 on some other applications. But as mentioned, that's not the bulk of it. It's this item down here, that's $7.371 million. It's hidden in every single individual project that we have. And when I say project, I'm talking about the road widening project, the interchange improvement project. It's all teeny tiny, and most people don't think about it, but it all adds up, and it adds up very quickly. And the problem is when you're going out there doing it as an individual project, you have data overlap that's very unnecessary. Typically speaking, and as what's happening with Georgia, when you're done with that data, it doesn't go to a central repository. It goes into the project folder because that's the project that paid for it, and that's the way that we as a DOT think about things. And then the next project comes along that's within the overall area and doesn't think to look at your project to get that data set. And then the other thing too is because it's all very small amounts of data, you typically end up seeing excessive amounts of labor going into deciphering that data because they don't want to build the tools to make sense of it. And so there was a really interesting case study that came out of New Jersey DOT that we took a hold of. And what they were finding was that on average for projects, that there was in excess of 180 man-hours per project on this data synthesis that if you could get to a centralized approach, sped everything up. And so we use that as a framework to show, look, we're asking for $5 million for this program, but in reality, you're going to be saving close to $4 million on an annual basis just by doing this in a more intelligent way. And so just as a quick explanation of how that looks, we were finding, in between $4,000 and $5,000 of data purchasing per project. That number that I was mentioning of excessive man-hours spent on non-traditional and non-standardized data sets, and then this lower number down here of that 234, that number has increased as the year has gone on, but for forecasted projects for FY22. But you can see that these programs are financially beneficial, and here's the example, and here's the proof of why they make sense. And the follow-up, I think this is where we get stuck, and when you go to present your case to your executive management teams is that just like we were, hey, we don't know what the value is going to be for this data-driven approach to deviate from standards. We know it's going to be positive to the department, but we can't put a value on it yet because there hasn't been good research around it. We know that this uniform data analysis capabilities is going to make for better justifications and visualizations in public forums to ourselves. But again, we don't have that evidence. And so again, we share these because I think they help color the picture more. But as far as the dollars and cents, it's really those previous slides to indicate that yes, this business model makes sense, and this is where we need to be going. And it's if you just work through the process, it will help out your agency, or in our case, agencies. And so I do want to give a shout out, and I like to leave with this before taking any questions, is as I was interviewing different states about how they were doing it, I was speaking with some folks up in Rhode Island, and this came from Mason Perrone, and they had purchased a very large origin destination data set, and so I'll just read it out for you. Even after we had developed our congestion management process and our travel demand model, we knew the data was limited. We needed enhanced data to infill the TDM. We needed enhanced data to infill the CMT. We were able to do that with our third-party data set. But once we had that data in hand, we got to ask ourselves a new question. What else can we do with this that we couldn't do before? And I think, that's where I like to leave this is a wide world, the world is wide open for us. And even though this has all been around for a while, and although we intuitively know this is the exciting part. This is as far as the traffic world goes. This is kind of that new ITS, if you will. And I think if we go into it with this attitude, we're going to be met with a lot of really exciting innovations in the near future. So that does it for us. And I think we head into the overall questions and answer time period now. Thanks.
Thank you, Kofi and Matt. Very interesting presentation. And Walter, you did a great job too. Sorry I was away there for a second. The internet connection gremlin struck right as Walter was about to finish, so apologize for that. Thanks for stepping in, Kevin. But yes, we are at the question and answer stage of this webinar today. Ben, I appreciate you taking the time to answer some of Andrew's question. Basically was asking about the cloud platforms and your opinions on them, and specifically ask about Snowflake and Amazon and Microsoft Azure. Is there anything else that you'd like to add at this time, Ben, to that question?
No, I mean, just there's the three major cloud providers are the one with the data center resources that they subcontract to different data center providers themselves. Then Andrew mentioned Snowflake, and Snowflake is a data management platform that has signed a partnership with cloud providers. So they started with AWS and then they went to Azure. I do not know if they have one on GCP. I'm not following them closely, but this is a very common pattern where even though you may appear like you're working on a different cloud, they are the three major ones are usually underlying them. It is although different for things like Oracle or IBM Cloud, which is pretty much an attempt for the traditional companies that IBM and Oracle are to try to offer their products using a cloud interface, using a cloud. So it's like, so they often have the similar systems, similar things make it easier to transition, but they lack this, how can I say that, in the velocity of obsolescence aspect I was touching on, they are using their fairly expensive, highly integrated and very, very reliable hardware, which kind of clashes sometimes with the cost model. So that's what I can say about cloud providers. Happy to answer more if people want.
Thanks, Ben. Let me just offer up again, if you have a last-minute question, we still have a few minutes here. I've got a couple questions that I'll just toss out in the interim, but if there's something on your mind that you'd like to ask, please go ahead and put that in the chat pod. Let me go to Walter, and just a question for you, Walter. If there's one thing that you'd like to highlight from your presentation today, what would that be?
Well, it is the fact that, can you hear me loud and clear?
Yes, yes.
Yes, it's the fact that FHWA is out there to provide the assistance. You know, basically I try to walk through the steps that we go through in facilitating these coordination meetings, having these regional plans developed. So basically, wanted them the audience to understand what we do, let them know we are there to help and also to provide the contact so that at least they do not hesitate to get in touch with us, either myself or Anita Vanderberg, who is my PI working with me for this task. Thank you.
Great, thank you, Walter. I see that Kofi included in the chat pod the Atlanta TISMO strategic plan.
Was that a question for me, Greg? We seem to be breaking up.
I think Greg has dropped out again. So, Walter, thank you very much. Let me go ahead and maybe take the baton and ask a quick question to Matt and Kofi. What do you see as the biggest obstacles in terms of moving forward with this data sharing and collaboration initiative?
So,
you know, right now, I'll speak on GDOT side, is that, you know, collectively at this, you know, collectively GDOT, ARC have come up with a solid framework. I think we're all on the same page. You know, now that we are coming out of COVID, you know, budgets are being rebalanced and agencies are kind of thinking back through, you know, their overall needs. I think that's, I would mainly just call it a speed bump, in that it's a slowdown that we're just kind of working our way through and just kind of waiting for the overall process to finalize. But I'll certainly let Kofi step in and chime in from his perspective on ARC.
Sorry, Greg's audio is out. I think we're having, this is going to be a comedy of errors for audio. It seems I think Kofi also lost audio, so we're hoping that Kevin can bring Kofi back on as a presenter. Give it 30 more seconds.
So, am I back on now?
Yes, you are. Go ahead, Greg.
Okay, great. Again, sorry for that. So I did have a question for Matt. You know, you gave a great presentation on how things were coordinated within the Atlanta area, and you also mentioned working with the Eastern Transportation Coalition. Do you feel like working with that larger coalition of multiple states has given you any insights or benefits to, development of your plan, and are there suggestions for others maybe to look at those types of arrangements if possible?
Yeah, that's a great question. So let me break it down, I guess, in a couple of ways. I think part one is overall data acquisition. It would be impossible for us to try to figure out how to do that on a state level without the ETC. I think that's for several reasons. I think that's the fact that, they just, when you're working with that big coalition of folks, you have a lot of experts all in the same room. And this is, civil engineers do not go to school for data management and all these different, all these different aspects. So it's hard to write a spec that, that I think on a state government level, on a federal government or even a local government, that you feel confident that you are getting a quality product. But in that case, right, because we have experts from all around the country, or in this case, all along the eastern seaboard, we can feel confident, and we have really solid systems to test the quality of the data, quarterly. So I'll start, I'll certainly start there. One of the other things that I didn't spend too much time on, but what we're doing internally within Georgia is basically, kind of think of it like the METCD of setting up our standards for data. So we're using the standards set up along the eastern seaboard through the ETC to say this is, kind of here's the bare minimum. And then we're building up on that a little bit. And the idea being that, we're not having to reinvent the wheel, number one. And two, we're giving the, similar language to the data vendors and sharing similar language with our partners so that, you're not confusing folks along the way. And so, I think the third part of that is that what I've seen from my involvement, especially that portion of the ETC is very engaged. You have participants that you hear from regularly that are taking action, that are pushing the envelope and bringing new ideas and new experiences to the table quite regularly. And I think because of the overall leadership of the ETC as well as the overall states participating, we were able to catch up, bring ourselves up to speed in terms of what was going on in the overall data management game very quickly, that if we were trying to learn it by ourselves, it probably would have taken 3 or 4 times as long.
Thank you, Matt. Certainly great insight there. And for those that may not be aware, the Eastern Transportation Coalition basically is a coalition of states along the eastern seaboard and some of the southern states. Matt, now is it up to like maybe 15 states that?
Sounds yeah, it sounds right. It was there was that was formerly the 95 Corridor Coalition, and it was changed as Tennessee and Alabama were added in recently. I think it was maybe last year.
So great. So I know there's other coalitions that have formed and are looking at forming in the future. So certainly that would be an opportunity there. We're getting towards the end of our time now, and I know we have some poll questions. So Amira, if you want to take that away.
Thank you everyone for participating in today's webinar. We have 4 quick questions for you that we would appreciate your answers on. The first one that's on the right is asking what kind of topics would you like to see in upcoming Adventures in Crowdsourcing webinars? The second question asks whether your program wishes to share or present any innovations that you have done using crowdsourced data. The third and fourth questions are asking whether you would recommend this webinar series to a friend or colleague. And lastly, how informative or useful you found today's webinar on modern data management.
And while folks are answering those questions, let me just hit one last slide that I had. Through our Everyday Counts initiative, we do have a website that is for the Everyday Counts 6 initiatives. There's 7 different initiatives that are involved with that. But with that, it gives information on each of the initiatives and talks about some of the resources that we can provide from federal highways as being part of that in the states and local agencies that have elected to be participants. We provide workshops and webinars like this, set up peer exchanges, provide technical assistance. We are starting a new effort in crowdsourcing with development of cohorts, discussion groups. This webinar today was part of the Adventures in Crowdsourcing webinar series that the Center of Excellence has hosted for us, and you can find past webinars that have been held on their website. They have been recorded, and you can go look at them on demand. And finally, with Everyday Counts, you can subscribe to the Crowdsourcing e-news, and then you will get information on a regular basis about things that are happening within the crowdsourcing area. And then finally, I will just mention that we have 3 co-leads for this particular innovation, myself, James Collier, and Ralph Opie. And if anybody has any questions about the innovation or about what Everyday Counts is or how you might be involved, certainly reach out to us, and we'd be more than happy to respond back and get you any information that you'd be looking at. So let's give a couple more minutes and let people finish up with their answers to the polls, and we're right at the end of our time here. Anything else that you had to add to wrap up, Amira?
I believe that is it. I'm just hopeful that more participants will answer the questions so we can get some good feedback.
Right. And Kevin, can you, we did have one question about, are the presentations going to be provided? Can you kind of talk about how that is?
Yes, I can. Thank you, Greg. So at the end of the poll portion here, I'll transition back to the other layout where the slides can be downloaded and the NOCO links and the FHWA links are available as well. I'd like to thank all the attendees for participating in today's webinar. I'd also like to thank our panelists and our moderator. I'd like to thank Greg, Ben, Kofi, Matt, and Walter for, we had some good information here today. Like I mentioned in the beginning, a recorded version of this webinar along with the presentation slides will be available on the NOCO website. On behalf of the National Operations Center of Excellence and our presenters, thank you for joining us today. And please, if you can complete the poll questions, that would be very much appreciated. And otherwise, have a great rest of your day.
All right, thanks. Great presentations, everyone.
Well done. Thanks, everyone.